For section 1.7, we're going to look at some of the different properties of real numbers. Properties are kind of like rules, okay? So, and they apply for certain things but not others. So the commutative property, you're like, oh my gosh, that's a big word, commutative. But to me, I see the word commutative and it reminds me of the word commute. What does the word commute mean? Right? If you've heard this word, you're probably a little older, but people talk about, oh, I've got a job with a commute. For instance, where I live in Bakersfield, we have a lot of people that actually drive to LA every day to work. They drive in, they work their 8 hours, they drive home. And they do that because that job pays a lot of money, and so it's worth it for them to drive to LA, get a lot of money, drive back to Bakersfield where it's a lot cheaper to live. So their family has a much higher standard of living. What does that commute mean? Well, it basically means when things move. Some tell me, some people tell me I have a commute every day. I drive, about 50 minutes to come into Porterville every day, work happily, and I drive home, where my family lives, where our schools are, and so that's what we do. I move every day to my job, and I move back. It's a commute. Well, commutative property is where we have numbers. I can do better than that. Give me a second. Either numbers or variables. They physically move or change places. So the general rule for this says if I have A plus B, I can have that A and B switch and make it B plus A. That is the commutative property of addition. Same thing with multiplication. If I have A times B, I can make that B times A. That is the commutative property of multiplication. Okay? Literally, you can move those and everything stays the same. You're like, really? I can just do that? Well, no, we don't just do anything. Let's check. What is 7 plus 5? Well, I know that that's 12, right? 7 plus 5 is 12. I'm asking you, is that the same thing as switching them 5 plus 7? When I commute, when I change the order, does it change the answer? 7 plus 5 is 12, 5 plus 7 is 12. These are all equivalent then. What is negative 3 plus 5? Well, they cancel, and I'm left with two positives, right? What if I put it in the other order and made it 5 plus negative 3? Would that change my answer? No, they would still cancel out, leaving me with two positives. So they're the same answer. Works with multiplication. What's 8 times 5 is what? 40? Isn't that the same thing as 5 times 8? If I count 8 5 times, I get 40. If I count 5 8 times, I get 40. I can move or change the order, and I get the same answer. Negative 3 times 2, we're going to argue is the same thing as 2 times negative 3. In both situations, there's only one negative, which makes the result negative, and 3 times 2 is 6. So you're like, sweet, I can do this with anything. Nope. The commutative property works for addition and multiplication, but not subtraction. 5 minus 3 is 2. If I were to just switch those numbers and put 3 minus 5, that's the same thing as 3 plus negative 5, I would get, these are not the same. You cannot change the order with subtraction without changing the answer. You can with addition, you can with multiplying. A divided by B is not the same thing as B divided by A. So A over B is not the same thing as B over A. A divided by B is not the same thing as B divided by A. Here's an easy example. What's 10 divided by 2? 10 divided by 2 is just 5, right? What if I were to flip that and put 2 over 10? Is that 5? Now I have some people that will just divide that and get 5, and that's a little scary. But let's try not to do that. This actually doesn't really divide in nicely. It just can be simplified. If I divide the top and the bottom by 2, I get 1 over 5. 5 is not the same thing as 1/5. These are different. You cannot change the order with subtracting and adding. With subtracting and dividing. Now, I'm lying to you, right? But you can move or change the places when I'm dealing with adding or multiplying. Whenever you see things move, that is called the commutative property. Associative property. Associative property, I think about the word associate. Who do you associate with? Friends, families, people you like, right? I think about high school, right? You have these people that you associate with. They are your friends, right? Or your groups. Associative property has to do with groups changing. Not the order, not commuting, but actual grouping changing. So if I have 8 plus this group, -1 plus 4, I can change the grouping with addition and group the 8 and the -1 plus 4 and get the same answer. You're like, no way. Yeah, I can. Look, 8 plus -1 plus 4, they cancel, leaving us with 3 negatives. 8 plus 3 is 11. 8 plus -1, they cancel, leaving me with 7. 7 plus 4 gives us 11. We can change the grouping and keep the answer the same. Okay? Here's our general rule for the associative property. If I have A plus B grouped plus C, that's the same thing as A plus changing the group B plus C. Notice what changed. It was not the order. Notice the A, B, and C stay in the same order. We just changed the grouping. Going back to the high school, A and B are best buds. A says something's kind of a jackass, and B says, forget it, I don't like you anymore, I'm going to go hang out with C. They can change the grouping. I don't know. If that helps you, if it's weird, just ignore it. But if it helps you, we can change the grouping, and the answer stays the same. This also works for multiplying. 2 times -7 is -14. -14 times 6. You might need to do that on the side. Is going to give us 24. 6 plus 2 is 8. 1 negative makes it -84. I could also do 2 times -7 times 6. 7 times 6 is 42. 1 negative makes it negative. What's 2 times 42? Well, if I double 42, I get 84. 1 negative makes it negative. The answers are the same. For addition and multiplication, you can change the grouping, you can change the order, and the answer stays the same. These are the properties right here in kind of a general form. This is showing you how they work. We're not just doing this for fun and giggles. I'm going to kind of show you right now why. The homework, these are definitions. These are things you want to write down, and I'm going to have some examples on the test where I'll say, what property is this? And I'll have an example where I change either the grouping, and you'll call it associative. And if I change the order of the things, you'll call it commutative. This is not a fun addition problem. There are no groupings, so I'm not going to worry about grouping here, okay? But I'm going to say, you know what, I would like to change the order of how I do these, because I don't really want to do 23 plus 41 is 64. 64 plus 2 is 66. 66 plus 9 is 75. And 75 plus 25 is 100. That seems more complicated than I want to do. So in mathematics we go, well, wouldn't it be easy if we could kind of group some things that kind of make sense? For instance, here I see a 1 and a 9. Those make 10. What if I grouped this differently, and I grouped the 2 and the 23 to make 25, and I did the 41 and the 9 to make 50. And I can change the order here. I can use the commutative property, and I can actually add these in different order. And this makes it a lot easier. I could even group the two 25s and get 50 plus 50, which is 100. And I can do this, and I actually could add this very quickly in my head by just stopping and going, wouldn't it be nice if I could change the order? Oh, it's addition. We can. This is the idea of the commutative property. I can change the order. Look at this multiplication problem. Somebody's going to go, oh, buddy, 25 times 69. That would be, I believe, 45. 18 plus 4 is 22. placeholder when I do the 6, or an X if you like that better. 30, carry the 3, 12, 15, 17, 25. Wow. 1725 times 4. 1725 times 4. 20. 8, 9, 10. 7 times 4 is 28, plus 1 is 29. 4, 5, 6. So we got 6,900. You're like, really? You're going to make me do this type of math without a calculator? What a punk, right? What if I change the order? Because that 25 times 69 was not easy to multiply. What two numbers would maybe be easier to multiply? How about the 25 and the 4? See, I can count by quarters. What's 25 times 4? 100 times 69? 6,900. Tell me that's not easier. That's the idea of these properties. We're not doing this just to make your life complicated. The idea is if I know when I can move things, then I can take problems that are somewhat complicated and maybe make them simpler. Okay? All right. An identity is where things stay the same. There is an identity for addition, subtraction, multiplication, and division. Here's the idea. A plus what makes A? Anything plus 0 makes it stay the same. A minus what leaves A? Anything minus 0 leaves it the same. So the identity properties for addition and subtraction say if I add nothing and I subtract nothing, I end up staying the same. The idea is that the left side and the right side look different, but really they're the same. Adding 0 and subtracting 0 changes nothing. What about for multiplication? I have people go, oh yeah, just stick a 0 in there. Oh, that scares me. Because anything times 0 is not itself, it's 0, right? Anything times 1 leaves it the same, and anything divided by 1 leaves it the same. These are called the identity properties. The idea is that I can add 0, I can subtract 0, and it stays the same. I can multiply 1, divide by 1, it stays the same. Why would we ever want to know this? Well, you've already kind of been doing this. 49 over 35. Let's simplify this. 49 and 35, if you got your multiplication like a multiplication table, if you know your rules, you know they're both divisible by 7. You also know if I do it to the top, to keep it equal, we do it to the bottom. Why? I don't know. That's what my teacher told me to do, and I got a gold star, and I felt good, so I just kept doing it, right? Well, look at this. By dividing the top and the bottom by 7, by dividing the top and bottom by 7, what is 7 over 7? Isn't that a 1? See, by doing the same thing to the top and the bottom, I am really dividing by a very complicated looking 1. I am dividing the top and the bottom by a 1 by doing the same thing, and I end up with 7 over 5. That means these two are equivalent. They are, I don't know why I have that, they are equal to each other. Because I didn't really change it, because I really divided by a 1. 49 35ths is the same thing as 7 fifths. They are the same value. When would I use the idea of multiplication? Well, easy. If I have something like 1/2 plus 3/5. We go, hopefully by now we look at that and you do not make that 4/7. That will make me very sad. I'm going to tell you right now, if you're making that 4/7, that is not a Math 55 issue. That is a Math 61 issue. Okay? I understand we all make mistakes sometimes. Don't. If you keep adding those and making those 4/7, we have a class that teaches that. This is not the class. I will review it, reinforce it. You need to know how to add fractions. So you need to know that these need a common denominator. 2 and 5, they both could become a 10. So what do? Well, I take the 1/2, and to make it a 10, I multiply that by 5. Can I just do that? No, we did taught. You do it to the bottom, you also do it to the top. Why? Why are we doing it to the top and the bottom? I got my gold star, made me feel good. Look, 5 over 5 is 1. We are multiplying by a very complicated looking 1. 1/2 is the same thing as 5 over 10. If I've got 1/2 of something and the other person has 5/10 of something, we both have half. 3/5, what do? I multiply the top and the bottom by. But by doing it to the top and bottom, I'm basically multiplying by a complicated looking 1. And that means 3/5 is really the same thing as 6/10. They are equivalent. And now that they have the same denominator, I can add them. So that's the idea of the division property, or division identity and the multiplication identity. By really multiplying by a 1, it stays the same. So I'm multiplying by complicated looking ones, I'm divided by complicated looking ones, and I know I'm getting answers that are equivalent. Inverse properties, right? What cancels out addition? No subtraction. But what can I add to A to get 0, right? Basically, anything, here's the addition one, anything plus its opposite will equal 0. A plus negative A is 0. That's an inverse property. 5 plus negative 5 cancels out, and I'm left with 0. Negative A plus A, that is anything, plus its opposite makes 0. Negative 10 plus a positive 10, anything plus its opposite makes a 0. We know these, I just want you to know their names. It's called the inverse properties. Basically, what cancels out? I can add the opposite to cancel out a positive number. What about for multiplication? You're like, well, division. Well, sort of. What we do is we say anything times its reciprocal. A times 1 over A equals, not 0 this time. When you cancel out multiplication, you get, well, check. A times 1 is A. 1 times A is A. And anything divided by itself is 1. Anything times its reciprocal gives us 1. This is the multiplication inverse property. If I take 1 over A and I flip it and put the A over 1 on the top, I still end up with A over A, which is 1. Anything times its reciprocal is 1. 15 times its reciprocal, 1 over 15. If I flip 15 over 1 to make it 1 over 15, I get 15 over 15, or 1. 1/3 times, flip it, 3 over 1 gives us 3 over 3, or 1. Anything times its reciprocal gives us 1. A over B, oh my gosh, what if I have a whole fraction, but I multiply it by its reciprocal, B over A? Well, I end up with AB over AB, which is 1. My 1 sucks. Is 1. Okay? What is the reciprocal of negative 2/3? What negative 2/3 times what gives us 1? Well, negative 2/3 times, flip it. Here's a question. Do I change the sign? We talked about reciprocal before. Reciprocal is where we flip it, but the sign stays the same. What if I forgot that? Well, then this would be wrong, because a negative times a positive would not be positive. For this to cancel out, I need to multiply it by its reciprocal, and it must stay negative, so that a negative times a negative is a positive, and 6 divided by 6 is 1. Negative 5 times what gives me 1? Once again, if I do the reciprocal of negative 5, I need to say, okay, then negative 5 over 1 becomes 1 over negative 5, or how about just negative 1/5? The sign stays the same when we do reciprocal. The fraction just flips. The two negatives would multiply to give me a positive, and 5 divided by 5 is 1. One more property, I think. I don't want to lie to you, but it's one of the easier ones. Distributing. When we are distributing, we are multiplying everything in the first group across the second group, across everything in the second group. This only works across addition and subtraction. I do not need to do A times B times C and try to distribute that. We already have something for that. We have that you just multiply them together. This is saying if I'm multiplying everything across addition, that A distributes or multiplies across everything in the second group. I end up with A times B plus A times C. Everything in this first group, this A, multiplies across everything across the addition in the second group. Same thing works for subtraction. I end up with A times B, but this time A times C is AC, but there is a negative, which means it's negative. Why would we ever want to do this? Well, a couple reasons. I'm going to show you one where we have to. I cannot add these, right? But I can distribute. I cannot do anything with this 2y, 7k, and 9m. So we'd be stuck mathematically with that group unless I can do something with that 7. I can. If the whole group is being multiplied by 7, then the 7 will just distribute. And I end up with 7 times 2 is 14. 7 times 7 is not 14, it's 49. 7 times 9 would be a minus 63m. And that's it. That's the distributive property. Are they equal? Like, I don't know, you just told me they were. Let me show you one where I wouldn't have to use the distributive property just to show you that it stays equal. Here I've got 2 times 3 plus 5. Would that be the same thing if I added first or if I distributed? Let's see. What if I added first? I would get 2 times 3 plus 5 is 8. 2 times 8 is 16. What if instead of adding, what if I had distributed this? You're like, why? Why would I have done that? You wouldn't, right? But over here in this example, we had to. We couldn't add what was in there. So we had to multiply it. What if I did that? Would it change the answer? Would 6 plus 10, 2 times 3 is 6, 2 times 5 is 10, would that give us the same answer? That's the key. When I distribute, I'm able to deal with that grouping. I'm able to get all that mess out of the grouping without adding. I can multiply the number that's on the outside across everything on the inside. Last example. How do I distribute this mess? You're looking at this going, okay, well, I can't do anything on the inside, so math shuts down. No. Can you distribute a negative? I see some people that will do this. I would prefer you to think of this as a negative what? There's a number there. It's like a negative 1. When I have a negative out there by itself, it's like multiplying by a negative 1. The 1 won't change anything. It just kind of gives us a number. It makes me feel a little more comfortable, right? That's like saying x is the same thing as 1 times x. If I have negative x, that's the same thing as negative 1 times x. That negative out there technically has a 1 with it. We don't write it, but it's there. Okay? So what does this do for us? Well, you need to remember your rules for multiplying. A negative times a negative makes that x a positive x. No, you don't need to write the plus sign. I just like to emphasize. The negative times the negative makes that negative 3 into a positive 3. And the negative times the positive changes that positive 6x to a negative 6x. Oh, technically I'm not done. I do have some like terms. X minus 6x gives us negative 5x plus 3y. How did I know to do that? That's actually in our next section, going over adding, subtracting, like terms, how to handle those, what they mean. So if I just lost you there, that's fine. It's not going to be in this section yet. It'll be in the next one.